we've constructed the power station with a number of thoughts in mind. One is we wanted to create it in a robust enclosure. So we started with what's basically a job site box, which is lockable. It's heavy gauge steel, weldments, and rather than do what we did in our first generation or second generation power stations, which was use PVC or hybrid materials to mount everything, we've used structural components. So we've used some channel strut and large bolts like these, 1/2 inch diameter bolts. And we've created a frame, and this frame rests on the structure of the enclosure itself. And that's going to give us a positive separation between the energy storage devices, which are the batteries, which are located below this ridge. And this box was selected so that we could get up to 20 kilowatt hours of batteries. These are lithium iron phosphate batteries. We only have 2 at this point in time, so we have 10 kilowatt hours of storage here. Creating this frame also allowed us to create some platforms where we could put our overcurrent protection. These are fuses on the positive leads coming from the batteries. We've added a combiner. This combiner will allow us to combine up to 4 batteries, each battery having a 200 amp BMS. The bus in this combiner is sized for up to 1,000 amperes.
Can you define BMS?
Battery management system. So every battery has its own battery management system.
Built into the battery?
Built into the battery.
Okay.
And the enclosures of these batteries, not only are they lithium iron phosphate batteries with their own BMS, they're IP68. So they're designed to be suitable for marine environments, typically in the hulls of boats, where they might be exposed to salt water or fresh water or could be flooded.
Does IP have is that an acronym for something that is
well, there's
worth knowing?
Different enclosure specifications, just like you have in electrical systems. You may have a NEMA 3R enclosure, which is what this enclosure is, which is rated for outdoors. Mm-hmm. You wouldn't want to spray it with a pressure washer. And the IP, similar to the NEMA codes, the IPs, I can't even remember what it stands for, they're waterproofing ratings. So there's IP67, there's IP68. It's just a matter of looking it up and seeing if it's suitable for the intended purpose.
Okay.
And intended purpose is not what it stands for. It just
right.
happened to be accidental. So, so what we do is we combine the outputs of the batteries. We have 2 batteries installed this time. We could expand that to 4.
Where do the other ports?
The terminals would be right here.
Oh, here and here.
They stack.
That top, okay.
And then these 2 bottom terminals are open.
Why do they go bottom and then top for that? Is that
it doesn't matter.
Doesn't matter.
So I just connected them to lugs that would allow us to space these out nice and evenly, so people could visibly see what's happening.
Yeah.
But it wouldn't have mattered. We could put them all on the bottom or all on the top. Okay. So then they're combined.
So this is coming direct from the battery. This is going on the battery terminal.
This is
one of the
batteries.
batteries.
The battery. So that's one circuit. That's one battery.
Yeah.
Negative and positive. Right. And this is another battery, negative and positive.
What size fuses?
And these are the fuses. These are 200 amp fuses, but we could have picked them to be anything. The fuse is missing.
I see.
And the reason it's missing is this is wired up.
Yeah.
And so we didn't want the inverter to be energized yet. We're not at that stage yet where we're ready to power it up.
Is it just a drop on? It just goes on those lugs?
Yeah, it drops on, and then there's a lock washer and a nut that would be torqued down to a certain specification.
Okay.
Okay. So we're not going to have to take apart any of this, but we are going to have to remove all of the connection devices external to the box because we want to paint it, because when you drill these holes you remove the paint. And
that could rust.
What's going to happen over time, all of these penetrations are going to rust, and we're going to see rust stains run down. So what we're going to do, once we've agreed that everything is the way we want it to be, I'm going to take off all the external connection boxes and we'll paint the outside again. There's a primer coat on it now. As you can see, it was blue originally.
Yeah.
We won't have to take apart the entire system. We'll leave it blue internally. And then we're going to put our decals on here, which we'll see a little bit later on. So the inverter is a special kind of inverter. It's really not a solar inverter. It's an inverter. It's a charger. It's a communication device. It's pre-wired to a large extent. So if we look internally in the inverter, that's an arc flash shield. We can see starting from the left and moving to the right, we have our battery inputs, and then we have our overcurrent protection, which is
And that's
a breaker.
coming from the joiner box there, I see.
That's coming from the combiner that's combining the output of all the batteries. Okay, of course, when you combine batteries, you're combining the amperage. So if you put 100 amp hour or 100 amp batteries in parallel to, you'd have 200 amps. If you put 300 amps, and so on. So this inverter can handle up to 200. I believe it's 225 amp breaker.
It says
250 amp breaker. So that's okay. It just means if we try to put over 250 amps into this device, it's going to trip. So if I don't want to lean on that, you're going to crush my hand, which I like that left hand. It's kind of handy to have.
Yeah.
So then these are our PV terminals. These are the PV inputs. Right now we have what I would call our maintenance PV, which is these 3 modules on top. We have about 1 kilowatt there, and these are a special module. They're high voltage module because we needed to get to a minimum of 150 volts to get the inverter to operate in its MPPT range. So we wanted it to get into its power point tracking range so it would operate efficiently. So these were special modules that we ordered that would allow us, in the small footprint that we have, just 3 modules in series, to get up over 150 volts. So we've tested them recently, and they're running about 180 in full sun, 190.
So they're about 60 volts modules. They're wired internally that way.
Correct. And we've just wired them in series. We've brought them into this junction box. The ground wire you'll see is simply a bonding connector to the rails because we need to bond everything on this mobile station. So these rails are bonded to the enclosure, which are bonded to all the inputs and outputs, the connection devices, which is bonded to the generator, which is bonded to the trailer frame.
Which we're going to have to put a spike in the ground to hook
Ultimately
to.
will have to be bonded or grounded to an earth rod. Okay, so we can have up to 4 circuits coming in here. There's only 2 MPPT channels. So whatever PV we bring into the second MPPT channels, we can bring in up to 2 circuits. We need to make sure that they are of consistent voltage. They have similar pitches and azimuths, okay, so that those modules all behave like. So on that one channel, they would all be pitched at some specified angle, whether it's 20 degrees or 10 degrees or 0 degrees for that matter.
But there's also open ports here.
Right. So we could have brought 2 circuits into the first MPPT channel and 2 circuits into the other. The most PV that we can bring into this particular inverter is 13 kilowatts. So you can imagine we could have 13 kilowatts divided by 4 strings. Or we could have 13 kilowatts divided by 2 strings.
Just checking. Mustard and mayo?
Yes, please.
Okay. Sorry, D. We'll be right in. So what we have, once we get past the PV, we get over into our AC components.
Oh, you've left these terminated because you want to keep inactive right now.
Yeah,
That's
these
what's
are
going on.
for an array that you would add in the future.
Oh,
So if you went around to the inputs for the junction box that's on the outside there, we've already pre-wired the MC4 connectors.
oh, so
But they're
this
not
you
plugged
would
into
you would
anything.
wrap this with red to indicate it's positive, or this one,
Right,
whichever
one
one
is
it is.
positive, is negative.
Okay.
But because we could have someone make a mistake, and they could put
Yeah,
the
backwards.
switch
You want
the
to test always.
connectors.
Yeah.
So we would never wire this
finger.
indirectly for fear that someone would reverse the
Like
polarity.
we worked on the other day.
Okay.
We were checking the polarities.
And then you would damage the inverter. So to avoid that particular problem, I've just pulled the wires in. And when additional PV was plugged into here, we'd want to check the polarity here to make sure the positive
Yes.
was positive and the negative was negative before we landed them in these terminals.
And you would
So-
rather put them in the second MPPT, not in the first.
Well, they would have to be, because otherwise you'd have, unless they were pitched 0 degrees, and they had similar electrical characteristics, you wouldn't want to have them in the same MPPT channel.
Okay.
Right?
Yeah.
because what you're trying to do is optimize the voltage current relationship to maximize the power, and you can't do that if they have different pitches and different azimuths and they're different
Right.
characteristics for their eye.
So you would
eye
only
curves.
use this if you had another, it was possible to make something exactly the same as the roof
Right,
of this. Okay.
right.
But this
And-
gives
and
you the
then
flexibility of other
and-
pitches.
And
now.
you had, and it was a 330
Right.
watt module, which has a similar voltage. Okay, it has
Yeah.
a similar current characteristic.
Right.
So you'd want to look at the label here and go and find those modules.
Yeah.
If you wanted to add more modules.
To that MPPT, but otherwise you're free to put any other.
You're free to put whatever you have. So we could
Okay.
take some legacy modules that you have now, and we could run them all the way up to the maximum voltage that you'd want to have here. Your open circuit voltage would be around 450 volts.
Mhm.
But I suspect that any legacy modules you have laying around that are, 100 watt, 200 watt panels are probably going to be in the neighborhood of 20 to 30 volts. So you can get quite a few modules before you get up to the 450.
Yep.
Okay.
Okay.
So
By the way, are there fuses here too? Is that what I'm seeing?
these are not fused
these are-
internally. So what we have to do is we have to make sure that we have some kind of fusing between the solar array and these wires where you're going to plug into here, which is fine because I've already bought the fuses. They're inline fuses, and you
For the
can just plug
positive
them in
lead.
because they've got MC4 connectors on.
Okay.
You just need to use them. I haven't put them in, of course, because we don't know what we're connecting to, and I just
Right.
don't want them laying around or they'll get lost.
But you'd put it here
No,
somewhere. I mean,
no,
back.
I would put them externally because when it comes to fuses, you'll notice that I put the fuses for the batteries. I could have buried them underneath the inverter,
Yeah, and then they blow and you're in big
and
trouble.
then you've got a lot of work to get to them.
Right.
So whenever you have overcurrent protection, you want the overcurrent protection to be safely and easily accessible.
Mm-hmm.
Okay, and so someone doesn't have to jump through hoops to try to figure out, how do I make this work now?
Sure.
Did I lose my fuse? Did my
Right.
breaker trip?
Right.
These breakers aren't all set on the top of these devices. It's not by accident. It's by design. So these breakers in here,
DC
they
breakers.
are for all of our AC, whether the AC is in or
Oh, these are
out.
AC.
These are all AC. None of these
Okay.
are DC. This is DC. This
Okay.
is DC. This is all AC. So for those of you who don't know, alternating current. This is a 240 volt split phase system. So we're going to have two hot legs. We're going to have one hot leg, another leg. So each one of these being 120 volts, you're going to have a neutral, and you're going to have a ground. So these are all 4-wire systems, okay? So every one of these breakers is going to have two hot legs. The difference between these two legs is 240 volts. The difference between any one leg and the neutral is 120 volts. And we're going to have a ground to bond everything together and earth the circuits.
Mm-hmm.
So the first one is your grid connection. So when available, the system can be plugged into the grid.
Mm-hmm.
And you can imagine a system like this that could provide backup, or it could provide peak shaving, or it could provide load shifting, or it could provide nighttime power, or it could offset expense of electricity. And how might that work? Well, this inverter, when coupled with a battery, without any solar, without a generator, simply a grid source, could actually charge the batteries at night when electricity is inexpensive, 7 cents per kilowatt hour for a typical time of use customer. And during the day when it's 21 cents per kilowatt hour, during periods of peak demand, we would forego the use of utility power at 21 cents, and we would draw down the batteries, we would invert it, and we would offset that expense with 7-cent power, and we would repeat the cycle.
But wouldn't you also have to factor in the long-term cost of battery replacement because you're cycling the batteries? So there's got to be some sweet spot.
Sure. So there's always the spreadsheet calculations that one has to do, but these particular batteries, in addition to being IP68 or marine grade batteries, they're not lead acid. They're lithium iron phosphate. So LFP batteries, you'll Google it and you'll find the chemistry of LFP batteries. And LFP batteries are a fairly recent thing. We're talking the last half a decade. In fact, I think the chemistry that we're using today for the lithium iron phosphate batteries originated in Germany in 2019. So this isn't something that has a legacy of 50 years or of a lifetime. These are
Hold on, I'm going to start another file.
Yep.
1 second.
Yep.